Okay, we are recording this session. So again, a doctor believes that the proportion of births in this country on each day of the week are equal. The word uniform, guys, means equal for all categories. So please understand the meaning of the word uniform. So if I tell you my grade distribution is uniform, that means I give the same number of A's as B's, as C's, as D's, as F. That's what uniform means. A simple random of 700 births from a recent year is selected and the results are below. At alpha equals 0.01, is there enough evidence to reject the doctor's claim? So here's how we start, guys. HO and HA. Remember what I said last week. HO means the distribution is as claimed, and then HA will be the distribution has changed. So you can write this one. Distribution of births is as claimed, or you can say uniform. And this is where the claim is. And here distribution of new births has changed, or different from expected, or is not the same as above. You can just put this language, guys. All right. I could do this using the table and show you how to find the test statistic, but I'm just going to do the shortcut and show you how to use the calculator to do this. And I'm also going to show you how to use Statcrunch. Actually, I sent a couple videos to my students in not in synchronous section. I will share those videos as well with you and how to use Statcrunch, but I can demonstrate that as well since we meet live here. So the next step, guys, this is step number 1. It's very easy problem if you just know how to follow the step. We need the test statistic. This is the formula for the test statistic, by the way. Remember, guys, last Wednesday when we did all the O's, all the E's, we subtract O from E, then we square them, then we divided by the expected values, and then we added all of them up. But there is a shortcut using the calculator to do this. So let's do that on the calculator. So I'm going to bring the calculator up. Okay. So stat, enter, and we're going to put the data in L1 and L2. L1 is going to be the observed values, and L2 is going to be the expected values. Do you guys see the calculator as well that I'm projecting?
Yes. So you're saying L1 would be like the frequency?
Yes, the frequencies. Okay. These are called the observed values. Always those numbers that he gives you will go to L1. You have to do some work for L2. You have to find the expected. So these are the observed. Okay, for L2, guys. Each observed values has an expected values, and then we'll talk about them after I put him into the, after I put the observed values into the calculator. So you put 65. Let's do it together, guys, because once you do it, you won't forget it later. 103. What we did last week, guys, he'll give us percents. Since I have 7 categories, he should have given us 7%, and we'll take the percent and multiply by the total, which is 700. But here he didn't give us a percent, but he says he believed that the distribution is uniform, it's the same. So what if the distribution is the same and 700 bursts in 7 days? What do you expect we should get each day if the distribution was correct and was as claimed?
the same number as the frequencies?
Yeah, so what would be?
So we put in 65, 103, 114?
No, it's no, this is what we observe, but what we expect, the doctor thinks if you have 700, the number of births each day should be the same. So what would you do with the 700?
So would we just divide it and put 100
By
in for each
7.
day?
Just divide 700 by 7. What's 700 divided by
100.
7?
100.
100. Just put 100 everywhere. So it's very easy when he says uniform, guys. It's very easy. You just take the total number and divide it by the number of categories, and you will get your expected values. He didn't give you percents here. That's what he thinks. The doctor believed it should have been 100 each day, but that's not what we got. But the question is this very close to 100, 100, 100, 100, 100? I mean, 112 looks close to 100. 116 looks close, but I'm just looking at 65, 75. They don't seem to be very close. So probably the doctor's claim is wrong. Maybe we're going to reject his claim. We will see. So these L1 are the observed values, guys, and L2 are the expected values. And let me write them down here. So L2, it's going to be 100, 100, 100. And I'm going to write down how I got this. Take 700, divide by 7, which is 100. If you had 6 categories, guys, you would divide by 6. If you have 5 categories, you will divide by 5. If you had 3, if the question is about uniform distribution, that's how you do it. It's not going to give you percentages. Okay. I remember last semester I gave students same question with 4 categories, and I think I gave them the number 500. So all they had to do is take 500 and divide it by 425 and put it in L2. 125, 125, 125, 125. Okay, now we're ready to run the test, guys. So you go to Stat, Tests, and then scroll up. Look, it's goodness of fit test right here. Okay. Oops, I picked the wrong test. Stat, tests, up. Now, goodness of fit test. Observed values, L1. Expected values, L2, so that's real good. Degrees of freedom. Degrees of freedom is number of categories minus 1. So what would it be in this case, guys? Not 5.
4.
How many categories do we have? 1, 2.
It'd be 6.
Yeah, 1, 2, 3, 4, 5, 6, 7. Minus 1 will be 6. So I'm going to change this to 6. So you go to Stat, Tests, chi-square goodness of fit test, observed L1, expected L2, and degrees of freedom if number of categories minus 1, which is 7 minus 1, which is 6, guys. Okay, there you go if you want to see that. And now I'm ready to just hit draw. If you want to see it in action, look, right scoot. Chi-square is a right scoot test always. So if you sketch it by hand, this is how you sketch it. So you're going to see the p-value, and oh, the p-value is very small, and the test statistic 26.8. Okay. Step 3, p-value. Let me just move up. Okay, I'm gonna write down what it says, 2e minus 4. So can you interpret this, guys? Don't put 2 as an answer. That's not correct. It means you have to move the decimal place 4 digits to the left. Well, where is the decimal? It's sitting right here. So it's going to be 0.0002, which is, of course, less than alpha, regardless what alpha is. Less than alpha.
Can you do it the other way where you don't draw it, where you just calculate? Because my X value, I did get the same thing, but my P value, I got 1.5784 and then the negative.
Yeah,
like 4.
yeah, that should be, yeah. Yeah. If you don't have the test, a student says doesn't have the test built on the calculator, there must be an older calculator. You can use this calculator that's built on the computer. I sent you the link to it, so you can download it and use this one. I can give you details later or send you the link one more time. So if you do this with the other way, yeah, if you do stat, tests, scroll up, goodness of fit test. And you don't have to do the draw, you can hit calculate. Yeah, if you round it, it's going to be, if you write 0.00015, if you round it, it's going to be 155 will just go up to 2. So it's the same thing. So we got the p-value less than alpha. Step 4, reject HO. Why? Because p-value is less than alpha. And step 5, guys, last step. There is enough evidence at the 0.01 level of significance. I don't need the calculator, so let me take it away. To reject the doctor's claim. That the proportions of births in the country on each day of the week are equal. So he's wrong. We are rejecting his claim, so we think they're not equal. And a strong evidence, guys, I mean, probably you noticed that here, when you look at the distribution, they don't seem to be like very much close to each other. Look at the 65. Seems like there are less births on Saturday and Sunday. So can someone control when they're gonna give birth? Probably not, but it's happening that Saturday and Sunday, they're not seeing as many births as the other days of the week. And that's why the claim turned out to be not valid claim. It was wrong. We rejected the claim. Okay, any questions about this, guys? So this is another example in how to use section 10.1. I'm gonna do another one. Chord. So we're doing number 9 on page 533. Take a note of this. A research firm claims that the distribution of the days of the week that people are most likely to order food for delivery is different from the distribution shown in the figure. Different from. So what do you think the claim is going to land, guys, in the null hypothesis or alternative hypothesis?
Alternative.
Alternative, because different from the distribution given in the problem will be alternative always. You randomly select 500 people, so we already know the total. and record which day of the week each is most likely to order food for delivery. These are the frequencies, are the observed values, guys. These are the O's. We have 7 categories. The table shows the results at alpha equals 0.01 test, the research firms claim. And these are the percents, guys, that we're gonna need to compute the expected values. Before even you use your calculator too, you need to find the expected values before you put them in L2. So let's do this, and then we'll go to the calculator to find the test statistic and the p-value. So let me write down the null and the alternative hypotheses. Okay, so number 9, page 533. That's number 9. And you start with HO, the distribution of the days of the week people order food for delivery is as claimed. Or is as given in the problem. You can do any you can write anything here. See, I'm not changing how we state HO. So HA is going to be is different. The distribution of the days of the week people order food for delivery, you can say has changed or is different than expected. Or you can say has changed. Either one would work. And that's our claim, guys. Okay, let's see if we have anything in the chat. Okay, yeah, some students are experiencing technical issues, so I'm recording this session anyway. All right, so now guys, HO, L1, you're gonna get the frequencies, the observed values, and L2, we're gonna put the expected values, and I would like to do the expected values, we're gonna do them together on the calculator. So the observed values are given for Sunday, it's 43, 16 for Monday, 25 for Tuesday, 49 for Wednesday, 46 for Thursday, and it goes up on Friday, guys. 168 people order food, and then on Saturday, 153. Now for L2, look what we're gonna do, guys, for L2. Okay, we start with Sunday. What's the percent for Sunday right here? It's 7%. You have to do 7% of the total, which is 500. Then for Monday, it's 40%. We're going to do 4% of 500 and so on and so forth. So that's going to be 7% of 500. Let me write it down. 4% of 500. And the next one, just make sure that I see it clearly. Tuesday is 600, 6%, and Wednesday is 13%. So 6% of 500, 13% of 500. And then on Thursday, just to show you guys. On Thursday is 10%, on Friday is 36%, and on Saturday is 24%. If you add up all the percents, they should add up to 100. So 10, 36, and 24. %, 500, and 24% of 500. Since I started here with Saturday, you have Sunday, you have to start with Sunday. It's the same thing. So what's 7% of 500, guys? It will be 0.07 times 500.
35.
Yeah, that's a 35. And then 0.04 of 500. You can do the calculation when you put them on the calculator if you want, but I'm just going to do them right now. 6% of 500 is going to be 30. 13% of 500 is going to be 65. 10% of 500 is going to be 50. 36% of 500, guys, it's going to be 180. And 24% of 500 will be 0.24 times 500 will be, which is 120. Okay, we're ready to show you how to enter those values into the calculator. So let me just bring the calculator up. There you go. I'm going to clear it. Stat. Edit. Okay, if you prefer that I use L1 and L2 all the time, I'm just going to do that. So L1, let's list them. I got 43. So we are entering the expected values right now in L2. 30. Next one is what, 65. So you think it's pretty much the same. If L1 and L2 are very much the same, guys, that means the distribution has not changed. If you think there's a big difference, so probably the distribution has changed. But if the numbers are very close, it's very, just probably you can say it did not change. But if they're not very close, it's a tough question here. 180, what did we have? 168, yeah, 168 and 180 are close. And then the last one, we had 120, 153. There is a big difference here, 33 less. Enter. Okay, guys. So we're ready to run the test. You go to Stat. Goodness of fit test. Okay, L1, L2. Degrees of freedom is 6 because I have 7 days minus 1 is 6, so it still work. And if I want to do a draw to show you the p-value, watch, guys. So this is the test when you have more than 2 proportions. Here we have 7 proportions. So chi-square, guys, as you can see, it's 17.595, and the p-value is 0.0073. And that's all I need from the calculator. So let me write them down and then I'll remove the calculator. 17.55595 and p-value is 0.0073. Okay, I don't need this. And let's continue. P-value, guys, is less than alpha. We reject HO. And you state there is enough evidence at the 0.05 level of significance. You can say to support the claim that the distribution is different than expected, or to conclude that the distribution of the days of the week people order food for delivery has changed, or is different than expected. That's what he asked. Days of the week people order food for delivery. You just can copy it, guys, and paste it from the book. Is different than expected. And that concludes the question. You can see once, guys, you pick up L2, it's very easy. Just put in L1 and L2 and run the goodness of fit test, and you're all set there. Any questions? So this is Statcrunch, guys. You have to enter in variable 1 the observed values and in variable 2 the expected. So I'm doing that now. 25, 49. I should get the same answers. 46, 168, and 153. And now let's go to expected values. These are the ones that you have to do by hand. So we got 7% of 500, which is 35. We got 20. We got 30. We got 65. We got 50. So for students who said that doesn't show on their calculator, they can also use Statcrunch to do this problem. Watch, very easy now. You go to stat. You see where it says goodness of fit right here. Chi-square test. Observed, where are your observed? Select the column. I just named the column observed so I don't get mixed up. And here expected. And that's it. Compute. And you can see, guys, chi-square is 17.595. That's what we got. And look, the p-value 0.0073. That's what we got as well. That's all you need from Statcrunch. And then this is less than alpha, which is 0.01, a level of significance to conclude that the distribution of days of the week is different than expected. Any questions?